Okay. Let me see. Am I audible or not? Okay, I think I'm audible. Okay. Let me see. Am I audible or not? Okay, guys, कैसे हो सब लोग? We are so back at the stream. आज हम करने वाले हैं merge sort. Let's see. आज हम मे बी 5 या फिर 5 नहीं 5:30 तक तो करेंगे. Let's see. पूरा लेक्चर ही आप भी का टारगेट है वन सिटिंग में. Let's see.
And welcome back to the channel. I hope you guys are doing extremely well. So this is another lecture from the Strivers A to Z course. In case you're for the first time here, this is India's most in-depth DS Algo course. Why do I say that? Because this course has 456 modules and we will be solving more than 400 plus problems in this particular DS Algo course. You can buy any of the paid courses on the market. You can check out all the free courses on YouTube. You will not find such a comprehensive course on DS Algo throughout the market. So in case you haven't checked it out, there's a link in the description. You can check out the entire course. So in the previous video, we have covered the step 2.1 module. In this video, we will be covering the algorithm merge sort, but there is a slight prerequisite to this algorithm. You should have covered the step 1.5 module. Just in case you haven't, please go and check it out. And guys, we are attaching the notes to all the problems and the video solution will be coming over here. Like if you see this one, the video solutions are attached and we'll soon be attaching all the notes. So please make sure you follow this particular sheet. The link will be in the description. So without waiting, let's get started with the problem merge sort. So what is merge sort? It is nothing but one of the other sorting algorithms. You must be thinking, but Striver, till now you have taught us bubble sort, insertion sort, selection sort. So why this another algorithm? If you remember, all of these three algorithms were taking big O of n square in order to sort an array. This is where merge sort is better. Merge sort takes a much better time complexity. We will be discussing the time complexity at the end of this video. But as of now, you need to understand that merge sort is a much more optimized sorting algorithm. Now, you know, sorting algorithm is nothing but it will sort a given data structure. If it has numbers, it will sort it according to numbers. If it has characters, it will sort it according to characters. If it has strings, it will sort it according to these strings. So as of now, we know that merge sort is a sorting algorithm. So what will be the flow of the lecture? The flow of the lecture will be, first I'll explain the algorithm completely. Then I'll go to the pseudocode. And since this is a recursive algorithm, I will go to dry run the recursion so that it gets into your head. So after these three steps, you will be able to code this particular algorithm in any of the languages because I will be writing the pseudocode. Post this, I'll be taking one of the languages and I'll be writing the main code. Again, this is something which is not that important. I will be focusing more on the first three steps. So without waiting, let's get started with the first step. That is the explanation of the algorithm. So in order to explain the algorithm, I will take this particular example of an array which has a size of 9. You need to remember two words. In merge sort, please remember that the algorithm means divide and merge. Please remember this. Divide and merge. So as you can see that this array consists of 9 elements. If I have to ask you a question, how do you divide 9 elements into two parts? You'll be like, okay, there are two ways in which I can do it. One is I'll say 4 numbers and 5 numbers. That's one of the ways. The other way you can say is 5 numbers and 4 numbers. That's two ways in which you can divide 9. Why? Because 9 is a odd number. So that cannot be splitted into two equal parts. That's why either you have to go 4 by 5 or 5 by 4. Now you can follow any of the path. I will follow the 5 by 4 path. So if I follow the 5 by 4 path, what happens is this algorithm divides the array hypothetically. Very important word. This algorithm divides the array hypothetically into two parts and says 3, 1, 2, 4, 1 and 5, 2, 6, 4. What do you mean by hypothetically? When I will write the pseudocode, I'll explain you. Okay. So as of now, this algorithm has divided the array into two parts. One which has 5 elements and the other which has 4 elements. I can say left part and the right part. Now what I will do is I'll always take the left part and I'll try to divide it again. So let's try to divide it again. If I try to divide it again, what happens is it has 5 numbers. Remember this, it has 5 numbers. So you can divide it like 2 by 3 or 3 by 2. Now, since in the first step, I divided 9 into 5 and 4, bigger, smaller, I'll follow the same pattern. I'll follow the same pattern so that I can easily write a repetitive code. Now, what I'll do is I'll try to divide it something like 3, 1, 2 and 4, 1. Remember one thing, you can also divide it as smaller, greater. That is completely okay. How you divide it doesn't matter as long as you divide it, okay? But make sure you follow the same pattern. Like over here, if you see it was 5, 4, that is greater, smaller. So follow the same pattern of division in the future as well for odd numbers. Okay, so next, 3, 1, 2. Go ahead and divide it. I follow the same pattern and let's say divided. No, we cannot, because can this be divided further? The answer to that is no, we cannot, because it's a single number and you cannot divide a single number. So this is where you stop. You say, the moment I get a single number, I stop. And you perform the second half of the algorithm that states, please merge them. So what do you mean by merge? It is 3. So I'll write 3. It's 1. So they are basically two hypothetical array consisting of 1
आवाज
numbers.
कमी करतो का थोड़ा?
So if there are two hypothetical arrays of 1 numbers and I want to make it a single array, what will I do? I'll say, okay, let's
आता नाही.
merge it. And
आता
you
नाही
try
येत.
to merge it into a single array consisting of these two numbers, but in a sorted way. So if I have to say, okay, I have 3, I have 1. And if I have to fill the first position, I have to make it sorted. Whom will I take? Will I take 1? Will I take 3? The answer to that is, I will take 1. So I take 1. Next who is remaining? 3. So I've merged it. I'll explain merge in detail as the array gets bigger. But as of now, what you can say is, okay, we come back. We come back. Whenever it's a single element in both sides, we come back, we take them, and we merge. And on merging, this will become 1, 3. This will become 1, 3. Array gets bigger. 3. So I've merged. I have 3. I have make it now. And you perform. What do you mean by merge? It is 3. So I'll write 3. It's 1. So they are basically two hypothetical array consisting of 1 numbers. So if there are two hypothetical arrays of 1 numbers and I want to make it a single array, what will I do? I'll say, okay, let's merge it. And you try to merge it into a single array consisting of these two numbers, but in a sorted way. So if I have to say, okay, I have 3, I have 1. And if I have to fill the first position, I have to make it sorted. Whom will I take? Will I take 1? Will I take 3? The answer to that is, I will take 1. So I take 1. Detail as the array gets bigger. But as of now, what you can say is, okay, we come back. We come back whenever, and on merging, this will become 1, 3. Divided into this portion. Now, this 3, 1, 2 was divided into this portion and was divided into this portion. Can I say the left portion got itself sorted and now the right portion has a single element? Can a single element be further divided? The answer to that is no. So your next step will be the two hypothetical arrays. One is 1, 3 on the left, one is 2 on the right, and you'll try to merge them into a single because there are two hypothetical arrays. And if you carefully observe, the left array in itself is sorted and the right array in itself is sorted. So now I will go across and hypothetically try to merge them. If I try to merge them, they will give me 3 elements in the sorted order. Now tell me one thing. Do you take 1 or do you take 2 in order to fill this first position? It'll be like, hey Striver, I will take 1. So you took 1 and you did not take 2. So the moment you've taken 1, the next you will say, do I take 3? Do I take 2? Like I'll take 2. So you took 2. Next you're just left with 1. So you will take 3. Again, I'll explain this algorithm in depth. Do not worry. So we basically merge them. Again, merge them. So we get 1, 2, 3. The merging has completed. So can I say, initially when I went to the left, we had 1, 2, 3. And when we went to the right, we had 4, 1. So the left portion has divided and merged itself into a single sorted array? It has. It's time to go to the right. Let's go to the right. So the moment you look at the right, it has 4, 1. So we again try to divide it. So if you try to divide it, it will be 4 and 1. Can I say we can stop over here because they are single elements and they cannot be further divided? Yes, we cannot further divide them. So what we do is we stop. Now, if it is 4, if it is 1, and if you have to merge them into a single sorted array, first 1 will come, then 4 will come. So what will happen is they will try to merge them and you will get 1 comma 4. So can I say that this one went, got it sorted, this one went and got it sorted. So basically now they both will come back because the left half is sorted and the right half is sorted. If both of them are completely sorted, what will happen? So can I say it went left and it got itself sorted? It went right, it got itself sorted. It's time to come back. So they will get merged. Very simple. So let's write it again. 1, 2, 3 and 1, 4. And they will try to merge themselves into how many elements? Definitely, yes, 5 elements. So let's kind of now try to get into the algorithm. Now you know this is the smallest element on the left half. If I say there are 2 hypothetical arrays, can I say on the left, the smallest element is definitely on the beginning because both the arrays are sorted. So we will take 1. We will take 1. We have 1 over here. We have 1 over here. If I have to ask you, which one will occupy this? It can be any of the ones. If I take any of the ones, and maybe I'll just move it. Now, if I have to ask you, out of 2, out of 1, which will occupy this? You know the answer. It's 1. So you now move the pointer. Next, if I ask you, out of 2, out of 4, which one will occupy this? You will be saying 2. So I'll move the pointer. Next, if I ask you, out of 3, out of 4, which one does occupy this particular guy? You'll be like 3. And this will move out. Next, if I ask, which one will occupy this? You'll be like 4. And this moves out. So apparently, you got this entire thing sorted. So can I say this will become 1, 1, 2, 3, 4? Done. So this half is sorted. So we started with 9 numbers. We splitted them into 5 on this side, 4 on this side. 5 guys have been sorted. By the algorithm divide, 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 and merge, 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 they got themselves sorted. Now it's about these 4 elements. Can I perform the same algorithm of divide and merge on these 4? I can. So what I'll do is I'll again start, because now it's the right half's turn to get sorted. So I'll not again divide the 4 elements. And if there are even elements, how do they get divided? Into equal number of elements. So it will become 5, 2 and 6, 4. 5, 2 will become 5, 2. So again, can I say they will be sorted back into 2, 5. And now this one will take place. So it'll be like 6, 4. Again, it will come back. I'll say 4, 6. Perfect. Now, can I say this portion is sorted? This portion is sorted. So now they will come back. And how will they come back? Let's write it out. 2, 5, 4, 6. So both of them will get merged into how many elements? 4 elements. 2 or 4? Which one goes at the first? 2. 4 or 5? 4 or 5? 4. Sorry. Now, 6 or 5? Very simple. Got a bit clumsy. See, we went to the left. That we need to do. We need to merge them. 2 and now of size. Created an array of entire. Combine them. List. Display someone or you move the 4. Say I limit the compare. So it's put done the sorting. So the last step, what will happen? They come back, and this will be 1, 1, 2, 2, 3, 4. 1, 1, 2, 2, 3, 4, 4, 5, 6. 4, 4, 5, 6. So can I say, after I have completed all the steps of divide and merge, if you carefully notice, the last step was merge in the parts of the algorithm. So once I perform both of them completely on all the parts of the array that I get will always be sorted. This was the algorithm. Understand the pseudocode. First thing that we have to observe is, what are we doing? We are dividing.
हम्म चालू आहे चेक कर बरं एकदा लॅपटॉप वर कर ना लॅपटॉप वर कर यू युट्यूब वर जा एनटी आयुष 01 एनटी पे आंटी ना एनटी आयुष 01 हम्म हम्म तेच तेच ना लाईव्ह चालू आहे ना एक हम्म. आवाज येतोय फाइन फक यू अविनाश थांब वेट एंड वॉच 20 seconds डिले आई गेस एनीवेज हो हो ओके सो मर्ज सॉर्ट इज प्रीटी मच लाइक दिस बहुत मेस टाइप लग रहा है देखते टाइम तो सो द कंसेप्ट इज प्रीटी मच इजी खुद से अपने कैरे बनाता हूँ 9 साइज के विल बी बेटर फॉर मी So quick sort this like this way.
We're dividing the array into two halves. But logically speaking, if you're going to break the array down into two new arrays, and then again this array into two new arrays, again this array into two new arrays, will it make sense? No. This is where in the pseudocode we will try to play around with index. Instead of breaking them down into two new arrays, we will try to play around with indexes. Okay. So in order to write the pseudocode, what I've done is I've taken a very small array of size 5. Now you know the array indexing starts from 0 and it will go till 4 if the size is 5. So what I will say is, see, this index will be referred as my low. This index will be referred as high. So what does low and high means? Is the starting point of an hypothetical array, and high is the ending point of an hypothetical array. So initially we have an entire array that has to be sorted. So low is the starting point of that entire array, and high is the ending point of that hypothetical array. Got it? Okay, so let's try writing the pseudocode for this merge sort algorithm. So I'll go ahead and write the function name as merge sort, and initially I'll pass the array, and I will say in this array, initially, please consider the entire array that you have to sort. So the hypothetical starting point of this array is low, and this is high, which means take the entire array. So I'll pass him low and I'll pass him high. And initially, when this is called, low will be passed as 0, high will be passed as 4. Very simple. Let's go on. And as of now, I'll not write any condition. I'll keep conditions apart. So how do I write this algorithm? Let's try to observe something. What are we doing? Repeatedly, are we doing something repeatedly? Yeah, divide, 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 divide. We're kind of doing divide, 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 divide. And at the last step, we're trying to come back, come back. Does it give you an idea that you have to apply something like a recursion? Like you have to go divide, 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 and then you have to come back. It's kind of like recursion backtracking. If you've seen the lectures, you can try to relate it with recursion and backtracking. That's what we will be using. So what I will say is, okay, now what is the thing that I'll do? I'll try to take this array and try to break it down into two parts. That is what I'm doing. I'll try to take this array and I'll try to break it down into two parts, where I will take the first one to be 3 to 4. That's how I was doing the greater, like the 3 numbers at the first and then the 2 numbers at the back. So I'll say I'll divide it into two parts, the left and the right. That's what I'm doing. And then I'll ask, can you please sort this? Can you please sort this? Once both of them are sorted, I can actually again merge them. That's what the algorithm was. So I'll be like, okay, do I need to make a new array? No. This is where low and high comes in. I say, hey, listen, this is array indexing. So can I say this array is nothing but an array where the low is at 0, an array where the high is at 2? Can I say this? I can. So if I have to look properly, the low is at 0, the high is at 2. That's what I'm doing. So I'll go and say that, hey, listen, maybe find a middle index. So middle is going to be low plus high by 2. Very simple. So if you see over here, what will be this? 0 plus 4 is from 0. Hey, please go ahead and try to sort this array. Sort this array, which starts from 0, which is apparently low,
Low
and which goes
and
on
mid.
till 2, which is apparently mid. I'm asking him to do for this one, right? And sorts this. How will I merge them? Because both of them have to be sorted in order to be merged. So what I will do is, I will again say merge sort. And I'll say array, can I get the right half of the array sorted?
Low plus mid.
And I'll say array, can I get the right half of the array sorted? I'll be like, okay, in this array, which portion are you telling me to sort? I'm saying from 3 to 4. What is 3? That's nothing but mid plus 1, because mid was 2 till high. So what I've done is, instead of making 2 new arrays, I told the indexes. I told in this array, take from low to mid, which is take from 0 to 2, which is this. In this array, take from 3 to 4, which is this. Instead of dividing them into 2 arrays, I passed on the indexes and set them to one, sorted by themselves. Sorted. Once the portion from mid 1 to high is sorted, what is the next step? If you remember, the next step is merge. So probably I can say that, hey, it goes from low to mid, and the second half will be from mid plus 1 to high. So take these things, and can you please go to mid? The array, the first half of the array is very simple. It goes from low to mid, and the second half will be from mid plus 1 to high. That's what I'm saying. Very simple. Now, when do we stop? When do we stop is my question. We have to write that over here, because if you know If this is nothing but a recursion, merge sort calling itself, merge sort calling itself, it's a recursion. In order to stop recursion, you write something as base case. I hope you know that. In order to stop recursion, you write something as base case. So you have to write that base case. Let's analyze what is the base case. Let's go back to this example. What is the base case? Can I say when your array has one element, when your array has one element, so if I have to index it, can I say this is index 0, this is index 1, this is index 3, 2, 3, 4, 5, 6, 7, 8. Can I say these are the last indexes? And if I have to ask, what array is this? You'll be like, this array is something like from index 1 to index 1, where index 1 is the low, index 1 is the high. Can I say this is the array that represents this? Yes, because we are not creating a new array. I am saying this array is from index 1 to index 1, which is this, right? So can I say the moment we have the low, the left point, we have the high, the right point to be same, that's when we do not go and divide. We do not divide. We just go back. So
So
that's what the
it's
base case
was
will be. We write, hey, if at any moment
low
the
equal to
low
equal
tends to be equal to high
or
or exceeds high for that reason, or maybe it's somehow like it will never, but still, just for safety reasons, if it exceeds high, please do not, because there's no need to do any of the further algorithms. It's a
mhm.
single element array and it will always be sorted. Please go back. Please go back. So this is how the pseudo code will look like. Might seem a bit confusing, but now when I'll dry run by taking an example, it'll straight away get to your head. Okay. So we can say that the pseudo code has been completed. If at any moment the low tends to be equal to high or exceeds high for that reason, or maybe it's some, please do not, because there's no need to do any of the
कि ड्राई रन करने से पहले हम ही ड्राई रन कर लेते हैं एक बार। हम लोग कुछ ज्यादा बड़ा एरे नहीं लेंगे। दिख रहा है नहीं? हमारी फर्स्ट केस में ये लो हायर हाई, ठीक है। अब जब हमारा ये एरे अलग होगा तो ये हमारा पहला ये चलेगा ना अभी। मर्ज सॉर्ट एरे, एरे हमारी होगी लो टू मिड। तो एक मीठी मिड इंडेक्स है या फिर पोजीशन है वे? तो हमारा मिड अभी के लिए ये है ना। गलत कर दिया मैंने, 1 मिनट।
For the algorithms. It's a single element array and it will always be sorted. Please go back. Please go back. So this is how
ओके, सो ये हमारा मिड है ना। 3.5, तो इसका आएगा अभी। तो इसका मिड वापस आएगा। हाँ, हम्म क्योंकि इसका मिड है 1। यार समझ तो आ, अच्छा, और लास्ट में मर्ज, अच्छा मर्ज के लिए हमने अलग फंक्शन बनाया। और लास्ट में मर्ज यार नहीं है, फिर ड्राई रन उसको ही करना
the
पड़ेगा उधर।
pseudo code will look like. Might
दिक्कत हो
seem
रही है
a bit
बहुत।
confusing, but now when I'll dry run by taking an example, it'll straight away get to your head. Okay. So we can say that the pseudo code has been completed. But in order to understand this algorithm with clarity, we have to do a dry run of this recursive algorithm. Then only it will get clarified. So let's try to do a dry run by taking this particular example. So remember one thing, whenever this algorithm is called, it is called with the complete array. So the entire array has always been passed with this algorithm. And the initial low and high will be 0 and 4. Because that's what for this particular example it will be. Because initially I will pass on this entire array and ask merge sort to sort it. So what will happen? Will this first base case operate? Because no, low is still smaller than high, so it doesn't. Mid comes out. What will be the value of mid? Can I say the value of mid will be 2? So what happens is it goes ahead and calls the merge shot. It goes ahead and calls the merge shot. So let's copy paste the same algorithm. Let's do it. So I've copy pasted. So what we can say is this particular recursion call will call this particular function again, but this time it will pass the low as 0 and pass the high as 2. So apparently what happens is it calls for this guy. Remember how recursion works is first this will get operated, comes back, then this line gets operated. That's how recursion works. So that's why first the left portion will get operated. So the recursion call for 0 to goes. Now what happens? Does this line operate? No, this line doesn't operates. What happens? Tries to find the mid, and this time the mid comes out to be 1 because 0 plus 2 is 2 and 2 by 2 is 1. So 1 comes out. So this time again this merge shot gets called. But if the merge shot gets called, what will happen? It gets called for what? From 0 to 1. So it's like 3 to 2 is what it is getting. So we will go ahead and maybe again call this recursion. Let's go ahead and call the recursion again. So the recursions, this is 1. So what happens? The mid is 0 plus 1 by 2. this time is called for 0, 0. If I go into the diagram, it's something like for. So what happens is gets executed and it returns. So I can say the it's done. It's done. So if I have to go back into the chart, this goes back. Similarly, another merge shot will be called. Let's try to write this as well. And this time it will be called for from mid plus 1 to high. So mid was 0. So it will be like 1 comma 1 because high was 1. Mid was 0. Again the low. Both of these are completed. We have this as so. Can I say this? That I'm going back from here. And now we have this as sorted. We have this as sorted. Go back here. This merge happens. So it is a 3. It takes a 2 and it tries to merge it. Now we will write the merge algorithm afterwards, but let's understand this. So 2 comma 3, 2 comma 3. Perfect. Back from here to here. And we can say the 0, 1 is sorted. So this time this recursion will again be called. Let's try to write it. So what will be this recursion?
Mid plus
If
1, 1 plus 2.
what's the next? 2 comma 2. Comma 2. And if it returns, this time what will happen? Recursion. Now this guy has done the merge happens from 0, comma 3 and this will become 2, comma 3, comma 4. I hope you're getting the gist. So can I say after this, I'll again go back. And when I go back, now I'll try to just come back. Yes. When I go back, can I see this? That 0, comma 2 would have been sorted. And if 0, comma 2 is sorted, I'm done with this. And I'll go to the right part, which is having this. And similarly, this is done. So this will call it, right? And how will it call it? Let's copy paste and show it. If 0, comma 2 has been done. So can I say next is mid plus 1. So this is nothing but 3, high is 4. This time it goes and calls for 3, comma 4. Again, the same thing will happen. The mid will be like 3 plus 4, 7 by 2, 3. So it will be called for 3, comma 3 and then it will come back. This will be called for 4, comma 4. It will be come back and then this will merge both of these two elements. It's like it will be called for and we have 3, comma 4 sorted. So the last merge takes place between this 0, comma 2 that is what happens at the run is clear in terms of the pseudo code. It was very simple. First the entire array goes to the left, goes to the left, goes to the left, goes to the left and then merges. It always performs this recursion first, this recursion first, this recursion first. Once this is completed, then this. Once both are completed, then the much more depth. What I'll recommend you is take a pen and paper, write this code, try doing it all over again. Got it? So what have we completed? We have completed the. I'll recommend you.
Wait. अब इतने इंसिस्ट कर ही रहा है तो हम भी कर ही लेते हैं. सो या पहला फॉर एग्जांपल हमारा है इंडेक्स 0. अरे कुछ भी ले ले यार, 9 8. बेसिकली मैटर नहीं करता, वो अलग बात है, बट अभी के लिए ठीक है. तो हमारा इंडेक्स हमारा है 9, सॉरी 5. सो हमारा 0 है और ये 5 है. अरे शिट. क्या हो? कल आज दोन्ही कॉन्टेस्ट आता सर रजिस्टर कशाचे आज 8 असं का दरवेळेस वेगळं असतं ना. ओ फक. दोन डिवाइस घे. ओके. हम्म. तो अब ये होगा ठीक है एरे. हम वही एरे को वापस कॉल करेंगे. अब जो ये इसका मिड है इसका हाई होगा. इसका हमारा मिड क्या था 2 था ना, तो 0 कमा टू, ये वापस रन होएगा। ये हाई था, अब इसका ये हमारा ये क्या होगा, 1। तो ये वापस अभी ऐसा होगा। थोड़ा परफेक्टली इसलिए करोगे कि मेरा दिमाग में बाइंडिंग हो जाए, पता है बाइंड हो गया ना तो फर्क नहीं पड़ता। अब मिड है 0, तो अभी वापस रन होगा। दिख भी नहीं रहा होगा ना, मेरा सर बीच में आ रहा है। हम्म। नहीं, इस बार तो 0,0 आएगा। एंड इस बार ये टेस्ट केस पास हो गया, तो हम रिटर्न जाएंगे। रिटर्न हम जाएंगे इस पार्ट ऑफ कोड पे। ये हमें क्या बोल रहा है? मेरा यहाँ पे हाई क्या है, 0,1 ना, और मिड 0 है। तो यहाँ पे होगा 1, और हाई हमारा 1। कुछ फायदा नहीं होगा, वापस रिटर्न ही होगा। इस बार यहाँ पे रिटर्न होगा। और अब ये वाला फंक्शन चलेगा, ठीक है। ये वाला फंक्शन चल गया। तो हम वापस अब पीछे जाएंगे एक स्टेप। बेसिकली अब हमें ये रन करना है, सॉर्ट। नीचे वाला, ओके, नीचे वाला भूल ना जाऊँ। मिड +1 क्या है हमारा, 2। हाई भी 2 है, ये भी रिटर्न ही हो जाएगा। रिटर्न हो गया, तब परफॉर्म होगा इन दोनों का, इन दोनों का। अब रिटर्न होगा यहाँ पे। अब ये वाला कोड पार्ट एग्जीक्यूट होगा। फक, मैं जोन आउट हो गया, क्या था ये इसका? ओह गॉड डैम इट, 3,5। लॉल, 3,5 यहाँ पे पास होगा ना मेरे भाई। 3,5, 3 + 5 क्या होता है, 8। 8 का क्या होता है, 4। तो 3 और 4। फिर वापस रिटर्न ही होगा। क्योंकि अभी कितने का है भाई ये? 5 का है ना हमारा। हाँ, तो एक एक में ही हो रहा है। अच्छा, तो ऑलरेडी एक एक में हो रहा है मेरे भाई। हाँ, इसलिए तो ये ज्यादा मर्ज टिक नहीं रहा। हाँ, तो ये वापस मर्ज ही हो जाएगा एक एक में होते। ओके ओके ओके, नॉट बैड, नॉट बैड, नॉट बैड। मुझे ना इस चीज पे फोकस करना पड़ेगा कि मेरी एक एक लाइन एग्जीक्यूट हो रही है।
Viewers, take a pen and paper, write this code, try doing it all over again. Got it? So, what have we completed? We have completed the dry run left with the merge pseudo. Let's take a bigger example in order to understand the merge. 7, 8, and this is like 0, 1, 2. Merge will happen. I will call it like merge these two arrays, because if you know, this array when goes into depth, it will be sorted. It will be sorted like 1, 1, 2, 3, 4, and this also will go into the depth, and it will be sorted like 2, 4, 5, 6. This is something which all of us know for sure, that both of them will be sorted, and both of the array will be something like 1, 1, 2, 3, and this will be indexed from 0 to 4. This will be from 5 to 8. That's something we know. We just have to write an algorithm to do it. So we're writing the algorithm, okay? So we're saying merge.
बोर होगा ना मेरे भाई, इसलिए तो हो रहा है,
I'll
बोर
give
ही
you the
होगा।
array, and I'm stating you that the first half is from low to mid, and then you can go from mid plus 1 to high. So I'm giving you all the 3 parameters required. What I'll do is, maybe I'll just keep an empty data structure. It can be a vector, it can be a list. As of now, just imagine this is an empty data structure where we can add elements. Okay. Now, can I say that the left array will be from low to mid? And can I say the right array will be from mid plus 1 to high? I can. So I will keep couple of pointers. So I'll say, okay, left pointer is at the low. So that means left comes over here. And I'll say right pointer is nothing but at mid plus 1. So what happened? I'll say right is here. Now what will I do? I will try to compare these two and try to fill in this bigger array, the bigger array. I'll try to compare these two and try to fill in the bigger array. So what I will do is, I will now try to iterate till what? Till we have elements on the left, or till we have elements on the right. Can I say that means I will say while left is smaller than equal to mid, which means I still have element, and I'll say and right is lesser than equal to high, which means I still have elements on the right. Very simple. Now what I'll do is, okay, this is what I'll do. Till I have elements on the left, till I have elements on the left, on the right. So I'll now try to compare. I will say, hey, listen, if array of left is smaller than equal to array of right, so what happens? This and this gets compared. And if 1 is smaller than 2, I'll take 1 and I'll add it to our resultant guy. I'll add it to our resultant guy. So I'll say, okay, maybe we can name this as something else. Let's go and name this as maybe, let's say, temporary. That's a better name. I'll say temporary. Can you please add yourself the smaller guy? Array of left. And once you have done this, can you move ahead the pointer? Which means the left pointer goes to the next. Again, so basically what will happen is, now temporary will go temporary. Can you please maybe on till I have elements on the left, till I have elements on the left, on the right. So I'll now try to compare. I will say, hey, listen, if array of left is smaller than equal to array of right, so what happens? This and this gets compared. And if 1 is smaller than 2, I'll take 1 and I'll add it to our resultant guy.
So
I'll add
array
it
is
to our
equals to
result.
array plus 1.
I'll say temp. Once you have done this, can you please add yourself the smaller guy? Array of left. And once you have done this, can you move ahead the pointer? Which means the left pointer goes to the next. Again, so basically what will happen is, now temporary will have 1 with itself. Again, the comparison between 1 and 2 will happen. And this 1 will, again the comparison, when you compare 3 and 2, when you compare 3 and 2, the 2 will come. But the if only compares for lesser. So there will be a else. So else will guy that can ahead till this is not completed. So what will happen? This 2 will come and the right will move here. Now the comparison between 4 and 3 happens, and the left is exceeded mid. There is no one on the left. So what I will say is, after the end, if there is anyone on the left, which means if there is anyone on the left, because if this while loop is false, either it will be false because this is true or this is true. So If there are on the left, if there are on the left, I will still add it. I'll just take every one from the left and add it to my stuff. And if there are people on the right, because anyone will be true, either there will be on the left, either there will be on the right. If there are people on the right, which will be right high, and then I'll say temporary dot add array of right, and I'll do right plus plus. Quite simple. If that means if on left, copy them. If on right, copy them. As simple as that. So can I say at the end of the day, that means if on left, copy them. End of the day, I would have 4, 4, 5, 6. All of them in the temporary array completed till this step. We can say the left sorted array and the right sorted array have been put into a third array temporary. But we actually need to put it from low to high because that's the original array. Because it is in temporary. So what I'll do is I will probably loop. Yes, let's loop from there. And I'll say array of I. That means who is the first element? Temporary. Temporary must be keeping because it's a temporary array. It will always keep in the 0th index. So I'll always say temporary I minus low. That's it. First time I will be low. So what will this happen? That means it's probably loop. Yes, because it is in temporary. So what I'll do is I will probably loop. Yes, let's loop. I'll say for I from low to high is where I'll loop. Please loop from there. And I'll say array of I. That means who is the first element? Temporary. Temporary must be keeping because it's a temporary array. It will always keep in the 0th index. So I'll always say temporary. First time I will always keep in the 0th index. So I'll always say temporary 0. First time I will be low. So what will this happen? Low minus low. That will be 0. Next time I will indexes because it will be stored in a temporary array. It will pick up all these indexes and store in the correct or store it in the correct order bed. This was mid plus 1 to high. And they got together from low to high. That was the original array. Got it? This is how the merge will look like. I hope that does make sense. So now I can confidently say that you've understood the explanation. In them in the let's come to the compiler and try to code it. So we have given a
Okay guys, that's बहुत दिमाग फट गया पता है मेरा। और तो देख ही रहा था इसलिए। Well, let's take 2 minutes break, I guess. Hello guys, we are so back at the stream. Let's continue. ना कैमरा बंद कर ले। कैमरा कैमरा थोड़ी देर के लिए बंद रख रहे हैं हम, क्योंकि हमारे रूममेट्स नग्न है अभी, थोड़े से नग्न अवस्था में है, तो आप लोग कोई गलत संदेश ले लोगे। ओए मग माझं लॉजिक बरोबर आहे का ते? सेवन हा? अरे अच्छा, अरे असा की टोटल नंबर स्क्वेअर्स किती आहेत? अच्छा टीसीएस की लगातार गुड अच्छी तैयारी होते हुए।
function, we're given the array, and we're given
भाई खतरनाक।
always keep in the zeroth index. Compile it and try to code it. So we are given a function, we are given
हम्म
the array, and we are given this. So assume we are going to write this function, and we say void merge short, and I'll say let's take the array, which is this. Please make sure you pass it by reference low and high. That's what we require. And we know one thing: if low is equal to high, we're going to return. That's it. Otherwise, we are going to find a middle, which is low plus high by 2, mid comma high, mid and high. That merge where we'll be passing array low, mid and high. That's what the algorithm will be, and we can call ms with the array and 0 comma n minus 1, because that's the initial starting and the end position of the entire.
हम्म बरोबर आहे तुझं. मग काय लॉजिक लावलं? मग मग तिचं 85 येते. तिचं 85 येते. 85 बरोबर आहे. मग कमेंट्स मध्ये 38 म्हणतात. अच्छा. टीसीएस वाले पण होमवर्क देतात का? अरे भाई मला स्क्रीनशॉट पाठव. हा दरवाजा लावून घे, वळून घे वाटलंस तर. अच्छा त्याचा होय, ओके. हा नाही नाही,
Array.
मला वाटलं मी आता कॅमेरा चालू करणार होतो.
Just have to write the merge function, and I think we will be done. So let's write the void merge, and again make sure you take everything by reference array, and then low, and then you can take mid, and then you can take high.
काय
So can I just take
दीडशेला
a
भेटलं
temporary
ब्लिंकिट.
array? We can. And we can take the left pointer to be low plus 1, sorry, low rather, and we can
ऑर्डर
take
कशी
the
ते मला
right
सांगा,
pointer to
मला
be
डाएट
mid
कोक मागव.
plus 1, because we know the first array will be, like if I have to comment it, it will be from
अरे
low to
भोसड,
mid, and the second array, if you
आवाज
remember,
कमी
it will
कर.
be mid plus 1 till high. So let's see, let's write this. So we
Oh
say left
fuck,
is lesser than equal to mid,
what the fucking code is it, bitch?
and mid, and right is lesser than equal to high. Very simple.
नो वे भाई, नो वे मला हे
But we
समजणार
need
आहे.
a temporary array that is defined over here. We say, hey, array of left, are you smaller than array of right? If you are, can you please go ahead and get attached push back to array of left? Very simple. At the same time, you can do a left plus plus, and you can write an else, and you can say temporary dot push back array of right, and if
भाई
the
पूरा
element
कोड यही
into the
लिख रहे हैं भाई, मैं तो कुछ
temper
कर भी नहीं रहा.
head, you can go ahead and run this and see. All right. So we have understood complexity, everything. But
भाई
and then low, low plus from low high equal. We need a at the same time you can do a left plus plus, and you can write an else, and it and very simple.
भाई मी तो केलेलं आहे मर्चसॉट मानिक, मर्चसॉट. छी भाई, किती घाण आहे.
At the same time, you right. Once you have done this, make sure you put them into the array of the numbers will flow. And you can say array on this, since everything is by reference. Go ahead. The
हम्म. काय काय अबे ह्यांच्या टू सम होईना थ्री सम कुठं करू.
The numbers will rearrange
नो वे भाई नो वे शिट.
themselves in the array itself. Now I can go ahead and run this and see if it is running fine. I hope it does. It does. And now I'll quickly submit this. I write codes in one go. Wow. Nice. No syntax errors. So we have understood everything. But there's only one thing that is left, which is the time complexity of this merge sort algorithm. Remember one thing. What's happening? There's an n size array which is getting divided to n by 2, n by 2. Then this n by 2 is getting divided to n by 4, n by 4, n by 4, and n by 4. So at every step, they're
2 raised to
getting
n.
divided by 2, by 2, by 2, by 2. And if you remember the time complexity lecture, I have already told whenever it gets divided by 2, the time complexity is log base to n. Remember this. Now you might ask me, but Trevor, why? You're dividing it by 2 by 2, but why it is by 2? Right? Like simple. If I you're dividing it by 2, but why it is log base 2 n? It's very simple. If I have to write 16 and I have to divide it by 2, it'll be like 8 and 8. Add it, and then 1 is nothing but logarithmic number the division happens. That means it gets broken down into log merge half, and every time division by like this is half and this is half. Again, everything is in terms of near about. Okay, time complexities goes till near about log base 2. And then there is a merge happening. How much is merge taking? If I have to think of the extremest case, can I say this is of size 3, this is of size 2? So in order to merge 3 and 2 elements, I'm gonna require 5 steps at minimum. One comparison, it's like everyone is comparing in itself. It's like a near about steps because every element is comparing.
काय असतं त्याच्यामध्ये काय डिलिव्हरी बॉय मग हा का? आपल्या कॉलेज मधला आहे का घेन बमोजे जी फॉर घेन बाय जी
One by
फॉर
one,
गोट
and then it is put over here. So it takes. I have to go back to this There's so many things written, man. I have to go back this. Can I say this at the worst case takes big of n this time? Over here, it might take big of n by 2. Over here, it might take time complexity. But strive, wait. N, 1 step, 2 step, 3 step, 4 step. Who will be counting these steps? Wait. That is actually compensated. How? Because the merge will be counting these steps. Wait. That is actually compensated. How? Because the merge over here takes big of n. The merge over here takes n by 2. The merge over here will take n by 4. So the merge is taking lesser. So in overall, if you try to add it up in mathematical, you'll actually get somewhere near about best, average, and the worst case. But if I have to ask, hey, what is the space complexity of the algorithm? How much log n near about n into log base 2 n as the merge sorts time complex. So n log n is the best, average, and the worst case. But if I have to ask, hey, what is the space complexity of the algorithm? How much extra space are we using? They're using. So if you remember the algorithm is actually using indexes, no separate arrays. Is this the given array that they're using? Are they using any extra additional space? They are during merge. In every merge step, they're creating a temporary array, which at the worst case might take big of n. So the space complexity at the worst case is big O of n, near about big O of n for this particular algorithm. So with this, I will be completing merge short, and the time is 3:28 a.m. in the morning. As you can see, I cannot record in the day.
Okay, so guys, हाँ, so आज के लिए इतना ही, मतलब आज के लिए नहीं, फॉर दिस स्ट्रीम इतना ही करता है, बिकॉज क्योंकि मर्ज सॉर्ट से तो भाई मर्ज सॉर्ट का कोड देख के दैट एफिस हो गई। तो इसको पूरा हम ड्राई रन भी करेंगे खुद से, एंड एनालाइज भी करेंगे जितना हम कर सकते हैं अभी, जितनी कैपेबिलिटी है। सो विद दिस गाइस, खत्म करते हैं आज की स्ट्रीम। वी विल मीट एट नेक्स्ट स्ट्रीम एंड वी विल कंप्लीट अ क्विक सॉर्ट। थैंक यू।